Warning: this video contains clips and excerpts of a humorous nature not normally found in math class. These are intended to fight the adolescent condition known as short attention span, found heavily in the modern teen, especially when in school. The only thing you should attempt at home is the math. The rest, you just laugh at.
Hi, welcome back to AT Math. Today, 6-2, solving systems by substitution. Why it's easier than trying to hold on to this dog. Now, this has been the hardest of the three systems to understand year by year. So please don't go too quick. I won't go too quick. You don't watch too quickly. Go back in the video if you need to. Just catch things you might have missed. But we'll take it slow. See how it goes. Well, here's the idea. When I'm sick, you get a substitute teacher. So from me to the sub. Now, whether you like the sub or not, they're substituting or taking the place of me. In the eyes of the school, it's a one-for-one trade, so it's an equal substitution. So the idea is, normal teacher's gone, substitute steps in. One for one. In respects to linear equations, we'll be doing roughly the same thing. Take this equation, y equals 2x plus 5. So it says y equals 2x plus 5. Now the amount that 2x plus 5 is, I don't know. But I do know that that equals the y. So whatever 2x plus 5 happens to be, y is its equivalent. So it'd be like, hey, who are you? The 2x and the 5 say, I'm y. I'm equal to all of you. So later on that night, hey, where's x, and 5? And y says, nope, I'm substituting for today. Well, I thought it was funny. Anyway, but here's how this works. By the way, I'm going to intentionally use examples from the last section from 6-1 that we solved by graphing. This shows you that you can use either method and get the same result. Take a look here. I have y equals 2x plus 4, and now I have y equals 4x. Now, in this case, because y happens to equal 2x plus 4 and the y happens to equal 4x, they both equal the y. Well, I don't know what y is again, but I do know that 2x plus 4 happens to equal y, as does 4x. And since they both equal y, they both must equal each other. So, since these both equal y, they equal each other. So 2x plus 4 will equal 4x. Again, I don't know what the x is yet, but now at least I can solve, because I only have one variable. So, instead of plus 2x, I'll minus 2x. Minus 2x on one side, minus 2x on the other, and notice how I get 2x equals 4. Then, instead of times 2, divide by 2. Divide 2 to one side, divide 2 to the other, and there you get x equals 2. Now, if that is true, we could be able to plug in the x and get the same for y. In other words, you see me get the same y for each one. So if x does equal 2, as it claims, right down here, then it doesn't matter which I plug into, I should get the same y result. Therefore, let's take a look. If y equals 4x, or x times 4, and x is now 2, it becomes 2 times 4. 2 times 4 becomes 8. Let's try the other side. Y equals 2x plus 4. Well, 2 times 2 makes 4, and plus 4 more also makes 8. Since it's the same for each, this is a good solution. So we have the x and y. When x is 2, y is 8. This becomes a coordinate pair. So let's look back at 6-1. I went ahead and ripped it from 6-1 and see what it says. At 2, 8, notice how both lines meet, just like they did in 6-1. Take a quick break, then we'll try you try.
AA batteries are one of the most popular brand of batteries out there, and at an average cost of $5 for a pack of 4, you can easily find yourself paying hundreds a year to keep your electronics running. Well, with this amazingly simple hack of a 6-volt lantern battery, you're going to be saving yourself a lot of money. First, pick up a 6-volt lantern battery that can be found for around $4 to $5 at almost any store that carries batteries. Next, we need to peel off that pesky label to make things easier. After that, using a flathead screwdriver or other tool, we need to pry the top off the battery. These are usually attached pretty securely, so it'll take a little muscle to get it off. Once we get the top part way off, using a wire cutter, cut the wires that attach the inside to the casing. Once that's done, you won't believe what's inside. 32 standard AA size batteries. That's right, 32 AA batteries power this one 6-volt. Now with this little secret, you can power all of your electronics for a very long time for just a few dollars and save yourself hundreds a year.
And back. You try. Solve by substitution. Remember, if 2x minus 4 equals y and 1x equals y, they both happen to equal y, they must equal each other. Go ahead and try. This is what I got. Since they equal each other, well, okay. I went ahead and did something different, just to be a little harsh, no good reason. I went ahead and minus 2x to both sides. Well, okay. And so I have negative 4 equals negative 1x. Then I divided by negative 1. I flip this sign. You got to flip this sign. So if this side becomes positive, so is this. So x equals 4. If that's true, by the way, I can plug it into either one and get the same answer. If I plug it into here, 2 times 4 is 8, and 8 minus 4 is 4. And if 1 times x is 1 times 4, 1 times 4 is also 4. By the way, if you want to go back up here with this here, I could have went ahead and minus 1x to both sides. Here's what I could have done. Suppose I wanted to minus 1x from both sides. So I'll get x, or 1x, whichever you prefer, minus 4. The absence of a value is 0. Now, instead of minus 4 plus 4, notice how it works all the same. Either way, it's all good. So the coordinate pair is 4, 4, just like this. And we graph it, and there you go. Now we have x plus 2y equals 6, and x minus y equals 3. It gets a little choppy here. So let's first figure out what we need to do. What you do is you pick one of the two equations. It really doesn't matter which one. So I can take this one or this one, and what I'm going to do is I'm going to isolate one of the values, one of the variables. Either I'm going to isolate the x or the y. It doesn't matter which. Because this looks kind of easy to me, I'm going to pick this guy. Although I certainly could have picked this one if I wanted to. So I have x minus y equals 3. I'll go ahead and get x by itself. And how do I do that? Instead of the minus y, I'm going to add y to both sides. Notice how now I get x equals y plus 3. Now I realize it looks kind of funny seeing an x equals and not a y equals, but it doesn't make a difference. Remember that when these two meet, when these two cross, both x's and both y's are going to be the same. Therefore I can swap one out for the other. Here's what I mean. If x now equals y plus 3, okay, and that was under the x minus y equals 3, so this guy becomes this guy. So x minus y equals 3, remember, becomes x equals y plus 3, because I added one to both sides. I'm going to take this original problem over here, and the only difference is instead of the x, I'm now going to substitute the value that this x is, because remember, x and x are going to be the same. X equals x because that's where they meet. Therefore, I'm going to say, well, instead of putting this x value here, which is in this guy, I'm going to substitute the value of x over here. However, instead of putting the x in there, I'm now going to put the y plus 3. Here's what I suggest. I start by putting parentheses around the value, the variable. It really helps, because what I'm going to do is I'm going to stretch that out, and then when I take the x out, I'm going to put the y plus 3 in. You'll see. So this x is now going to be substituted for the y plus 3 right here. Notice how I just swapped the x value for what the equal value was, which was y plus 3. Now I have y plus 3 plus 2y equals 6. At this point, remember, y is 1y, as I put down here. So I got 1y and 2 more y. I combine to make 3y, as you see. 3y plus 3 equals 6. Now instead of plus 3, I'm going to minus 3. Minus 3 on one side, you minus it on the other. 3y equals 3, and then divide both sides by 3. Y now equals 1. If that's true, I can plug the y into either of the original equations. It should make no difference. It should give me the same x value. If it doesn't, I've made a mistake. So I'll plug it into this first guy. So x plus 2y equals 6. I've now determined that y equals 1 based on this. Therefore, 2 times y becomes 2 times 1. 2 times 1 is 2, so x plus 2 equals 6. And if that's the case, instead of plus 2, I'm going to minus 2 to one side, minus 2 to the other, x equals 4. Let's put it in this equation instead, though. So instead of x minus y equals 3, I'm now going to put the 1 back inside. So now it's x minus 1 equals 3. Well, okay. Instead of minus 1, I'm going to add 1. Add 1 to one side, add 1 to the other, and I also get x equals 4. Notice how it made no difference which one I picked. I could make a political joke, but I won't. Instead, now understand that you do not have to plug the x into both equations. I just did it to show you that it did not matter and that you will get the same y anyway. Let's take a short break. Alright. Now either way, we've determined that the x equals 4 and the y equals 1 from the last example. If you notice down here, that x is 4 and y was 1. Therefore, the lines are going to meet at 4, 1. Now if that's true, I plug them both in. I plug the 4 in where the x is and the y is where the 1 is where the y is. Notice how I get, in this case, well, I guess I didn't even do that. I guess what I did here was I just solved for y. So ignore this for a moment. Ignore that. Let's just concentrate on solving for the y equals. So instead of plus x, minus x to one side and minus x on the other. Now you could put 6 minus x, but remember I want the variable in front. So variable in front, then the y-intercept. So I'm going to put negative x plus x. If you prefer to put negative 1x, that's certainly fine too. Then instead of times 2, I'm going to divide 2. But if I divide this side by 2, I got to divide this side by 2. So divide 2, divide 2, divide 2. You get y. And remember, this is negative 1 over 2. So negative 1/2 x. And then 6 divided by 2 is 3. So this is y equals negative 1/2 x plus 3. On this side, to find y by itself, there was a couple different ways to play it. Here's the one way I did it. I went ahead and minus x to both sides. So I get negative y equals negative x plus 3. If I'm going to flip this sign, you got to flip this sign. So I'll flip this guy with negative 1. Both of these have to be flipped as well. Long story short, it just changes all the signs. So now positive y, positive x, negative 3. The other way to do it, you could have done it like this. In fact, let me make my life easy here. I'll just quickly clone a copy. Yikes. Clone a copy. I could have just done this instead. I could have added y to both sides. And I could have got x equals y plus 3. And then instead of plus 3, minus 3. And x minus 3 equals y. Means the same thing. So no matter how you want to do it, that's certainly up to you. But more importantly, you take these two guys here. Y equals negative 1/2 x plus 3. And y equals x minus 3. Notice if I graph, I start at 3 up. Down 1 over 2, down 1 over 2, just like this. And notice this guy, I'm at negative 3, up 1 over 1, up 1 over 1, up 1 over 1. Notice where they meet. Good grief, it's 4, 1, just like we just learned. Personally, I think doing a quick substitution is a lot easier than trying to find for y and trying to graph. But both will get you there. Like if you pay for something that costs $10, whether you give someone a $10 bill or if you give them 1,000 pennies. 1,000? Yeah, 1,000. Either way, it'll get you there. So it just depends on what you want to do. Quick break.
And saved, and let's see if everybody's okay.
Boy, Knight tried to jump over.
And we're back. Let's do another. 2x plus 5y equals 7 and 3x plus 2y equals 5. So What I want to do is pick a variable to isolate. It makes no difference which one. There's 4 I can choose from. So to understand, I can solve for this x, I can solve for this y, I can solve for this x, I can solve for this y. It makes 0 difference. The only thing is, you want to find the easiest possible, because when you stick it into the other one, you don't want to deal with some crazy fraction, even though they will all work. So I'll choose this, because I think this is the easiest, although none of them are easy to be sure. How do I isolate this x? First, positive 5y has to go. So instead of plus 5y, minus 5y. Minus 5y to one side, minus 5y to the other. So I get 2x equals negative 5y plus 7. Then instead of times 2, I'm going to divide 2. Divide 2 on one side, divide 2 on both of the others. So now x equals negative 2.5 or negative 5 halves, whichever floats your boat, plus 3.5 or 3.5 again. Here's where it gets a little choppy. Remember that this was the original. This is what I made. I'm now going to stick this x where this x is. So instead of 3x plus 2y equals 5, all I'm going to change is this x. This x will now take on this value. So I'll just rewrite this problem again, but give a good amount of space in my parenthesis, because I'm going to erase that x and put in the negative 25y plus 3.5. All I did was I took this and said, hey, you get bigger, x you go away, and this gets dropped right in there like that. Now, there's still 3 on the outside, and I can't tell you how much you need to write this out. If you try to do this in your head, good luck. I would have a hard time doing it in my head. So, take the x out, drop this in, see it, even though it looks kind of ugly, times it all by 3. 3 times negative 2.5 is negative 7.5y. 3 times 3.5 I think is 10.5, I'm pretty sure. Then plus 2y equals 5. So here's the tricky part. Okay, it was 3x, but now it's just 3 times all this junk. So what do? Just times the negative 2.5y and the 3.5 by 3. A lot of people will forget to times this by 3. They'll leave 3.5, they won't times it by 3. You gotta times it by 3. So times 3, but bam, negative 7.5y plus 10.5 plus 2y equals 5. Because these are both on the same side, we simply combine. So negative 7.5y plus 2y becomes negative 5.5y plus 10.5 equals 5. Then, instead of plus 10.5, we're going to minus 10.5, minus from one side, minus to the other. Remember that a positive and negative combining, the bigger number wins, and the bigger number's a negative, so the negative wins by negative 5.5. You know, really, I should probably want to separate these a little bit and just put this by itself. Put it like that here. So this becomes negative 5.5y. Remember, this got moved over. So you minus this, and now instead of times negative 5.5, we divide by negative 5.5. Divide on one side, divide on the other. Y equals 1. Now let's plug it in. Does it matter which one? Absolutely not. I'll plug them into both just to prove I can. Plug the 1 in here, so instead of 5 times y, now 5 times 1. 2x plus 5 equals 7, minus 5, 2x equals 2. Divide by 2 to both sides, x equals 1. On this side, plug the y in, so instead of 2 times y, 2 times 1, 3x plus 2 times 1, which is 2, equals 5, minus 2, 3x equals 3. Divide by 3, x equals 1. X equals 1 either way, y equals 1 either way. Let's plug them in. I plug in the 1, 1, and 1, 1. I get this 7 equals 7, this 5 equals 5. It doesn't matter, they're the same numbers. All that matters is it totals out. But we'll further graph to prove it. You don't have to graph in this section, but I want to show you this all works. So if I have this guy here, 2x plus 5y equals 7, minus 2x, then divide by 5, divide by 5, divide by 5. Y equals negative 2x, or 2/5 x, or whatever you want, plus 7/5, or 1.4. Over here, 3x plus 2y equals 5, minus 3x. Now I get 2y equals negative 3x plus 5, divide by 2, divide by 2, divide by 2. Y equals negative 3 halves x plus 5 halves, or negative 1.5x plus 2.5. Just let me graph it for you. Wow, see where it measures up at? Right here at 1, 1. So I don't care which way you use. I don't care if you graph or if you use substitution, but clearly substitution looks like an easier thing than trying to do all this. This is tricky at first. But it wasn't the only thing that was tricky for you. When you were about 9 months to 12 months old, and you were good at crawling, and you took that first awkward step, or first awkward climb up on your coffee table, or your kitchen table, whatever you tried to climb on, and you got on them little wobbly legs, and you were bouncing around, and it was hard, and boom, you fell down. And you climbed up again, and you held on for a while, then boom, you fell down, you cried, you got back up. And then one magical moment, you went ahead, and your parents remember this, you took your first step in your big old, inflated, cushy little foot, and then another, and then you fell, and you got back up. The point is you kept trying and trying and trying until eventually you walked faster than you crawled. Then you stopped crawling because you didn't need to anymore, and a new skill was learned. That took you probably a few months to master. This should take you probably at least a few minutes or a few hours to master. So don't be down on yourself if you don't understand this right away. It takes time. And with that lengthy speech, I think it's time for a break. And we're back. So you try. 3x minus 2y equals 5. Negative 2x minus 5y equals negative 16. Go ahead and pause it this time. I'll give you my answer, but it may be different than yours. Let's take a look. I went ahead and isolated this 3x. It was my choice. I just wanted to. So I added 2y to both sides. So I got 3x equals 2y plus 5. Divide by 3, divide by 3, divide by 3. All right. I got x equals positive, 2/3 y plus 5/3. That's just myself. This was the other side. So instead of the x, I put this all in here, and I made it complicated on purpose, just so you could see that it can be done. Negative 2 times this whole mess, I plug it in. Negative 2 times 2 is negative 4 over 3. Negative 2 times 5 is negative 10 over 3. Minus 5y equals negative 16. This becomes negative 1 1/3 y, combined with negative 5y. So I get negative 6 1/3 y minus 3 1/3 equals negative 16. I add 3 1/3 to both sides. Now negative 6 1/3 y equals negative 12 2/3. And I used a calculus. I kind of cheated. I divided both sides by negative 6 1/3. And I got y equals 2. Now I plug them in. Doesn't matter which side. So 3x times negative 2 times 2 equals 5. 2 times 2 is 4. Add 4, add 4. 3x equals 9. Divide by 3, divide by 3. X equals 3. Plug this in. Negative 2x minus 5 times 2 makes negative 10. Negative 2x minus 10 equals negative 16. Add 10, add 10. Negative 2x equals negative 6. Divide by negative 2, divide by negative 2. X equals 3. So the answer is 3, 2. Now if you did it different, that's great. That's how I did it. If I plug it back up here, 3 times x, 3 times 3 is 9. Minus 2 times 2 is 4. That equals 5. Negative 2 times x makes negative 6. Minus 5 times 2 is 10. Negative 6 minus 10 is also negative 16. Easy and peasy. Time for a quick break. Now we're back. Do it again, people. Hint. Isolate an x or a y right here. See what you did. I went ahead and isolated this x, so I minus y to both sides. X equals negative y plus 3. Just dropped it in there. Boom. Negative y plus 3 plus 4y equals 6. Combine these two to make 3y. So now I hit 3 plus 3y equals 6. Minus 3 minus 3. 3y equals 3. Divide by 3, divide by 3. Y equals 1. Plug them into either one. You'll get x equals 2. There's your answer. If you are one of the many who are going to have a little trouble with this, please, please, pretty please, come visit. See me before school. See me at homeroom. See me at lunch crunch. Make time, and I'll help you. Now let's do the word problem. Once again with our screaming sheep. Alright, and also you can follow along on page 393 if you like. Here's the word problem. One high-speed internet provider has a $50 setup fee and costs $30 per month. Another provider has no setup fee and costs $40 a month. Compare the two and determine when the cost will be the same. Now, if you're asking me where will I ever use this in life, oh, I don't know. Only every month in your adult life that you have TV, that you live on your own, because you're going to find that there's Comcast and there's AT&T and there's Xfinity and 1,000 others, and DirecTV and Dish TV and blah 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 blah, and they all offer you about the same shows. However, some things cost more than others, and it gets complicated because then they add internet bundling, or they'll add, free phone service, or this or that. And this is a $200 to $300 a month question when you add it all up. Now, I realize right now you enjoy your parents' free things, but eventually when they're not free, you'll care very much about how many things cost. So let's get back to this question here. So basically, one high speed, $50 for setup, $30 a month. Other, no setup, $40 a month. So let's go ahead and separate the two. I highlighted this in red for company 1. Hold on, what do you need, boy?
Nothing.
Okay, that's fine. $50 setup fee and $30 per month. So the month, we don't know how many months we're going to use it for, so that's the X, so 30X. The 50 is just one straight $50 fee. So that's 30X plus 50. This, there's no extra fee, just 40 a month, so this is just 40X. So I kind of sped it up here, but just 30X plus 50 and 40X plus nothing. So I'm comparing the two now. Here's the only difference. I said this Y, which is total cost, equals my 30X per month and $50 for the one-time fee, where this one, the total cost, the Y, is the 40X per month and 0 fee. Now, since both equal Y, they're both going to have to equal each other insofar as when they meet. Now, other than the point they exactly meet, one's going to be cheaper than the other, and that's where you get to determine that. First, we have to determine when they're the same cost, then we'll figure out what's better for us. So if they both equal Y, they both equal each other. So 30X plus 50 is going to equal 40X plus nothing. So what I'll do is I'll get rid of the 30X on both sides. So now I get 50 equals 10X. And now, instead of times 10, we divide by 10 to both sides, and X equals 5. So in other words, in 5 months, the cost would have been the same. Since most cable companies have you contracted for 12 months or 2 years or whatever, you probably want to find the one that's cheaper per month under this example. Although if there is no difference in cost, then you might want to do the other one. But that's completely up to you. In the end, you decide that. And I wrote here, by the way, should you care? Because 5 months is the breaking point. Meaning that if you have less than 5 months, go for the cheaper install cost. If you're going to have it longer than 5 months, go with the cheaper per month fee. Picking the right one will save you money. And of course, it's never that easy. There's always a special offer, or we'll bundle you, or you can take this freebie here, but then you have to keep us for 12 months or 2 years. So there's always that. And even though it's confusing, it pays to do a little research just like this, just like your Algebra 1 teacher's telling you, because it might save you $50 a year, and you might say, big deal. Yeah, maybe $50 is a little deal, but 20 years, that's $1,000. And I'll bet a lot of you could use $1,000 in your pocket. And what better way to put $1,000 in your pocket is to not put it in somebody else's. So there. Let's take a break and we'll come back. Now, you try. A Verizon cell phone you want costs $50 plus $40 a month for unlimited calls and texts. An iPhone you want is $200 plus $30 a month. How many months will go by before they equal the same? Now this of course means that you don't care whether you have Verizon or iPhone service, and you don't care about the apps or 1,000 other things. We're just comparing cost. And if you ask me, that's what I normally look at, is how much is it going to cost me. So let's break this apart. Oh, you done the you try, I hope. Let's see what I did. I broke apart the Verizon, which was $40 a month plus $50 from the beginning. iPhone, I put $30 a month plus $200 for the phone. So I put 40X, because I'm not sure how many months we're talking about, 40x plus 50 equals 30x plus 200. Now that I have this, I'll minus 30x to both sides. I have 10x left over here. Now instead of plus 50, minus 50. Minus 50 to one side, minus 50 to the other. 10x equals 150. Divide by 10, divide by 10. Seems like in 15 months, the phones equal the expenses. So if I plan on keeping the phones for more than 15 months, I can get the iPhone and not pay more in the long run. If I'm going to have it less than 15, I might want to get a Verizon and then buy a different phone later. Done. But you might want to do more examples on the whiteboard. I might have more examples for you in class. But we are flipping the classroom, so you are expected to do this, and I will expect you to come see me in the morning if you need help. But don't be quiet about this if you need help. See me, and we'll get you there. Thanks again. A little more complicated, a little longer. Here's a quick video to end us. Thanks again. Bye.
The Earth is a magical place. All the creatures on it just going about their daily business in peaceful, serene tranquility. Except for those creatures that are specifically put on this Earth to mess you up. The Earth is awash with these terrors, the last things seen by nearly everything that sees them. And today we're going to pit two of them head to head, the great white shark and the saltwater crocodile. And no, they shall not hypothetically fight each other. I've seen that. It's lame. They would never fight each other because the universe would explode if that much concentrated death was ever mixed together in one place. No. Today, Versus is going to explore how deadly they would be to humans. Specifically, you. For knowing how deadly a crocodile is, in general, would be really important if you were a wildebeest, but I'm guessing there are statistically insignificant amount of wildebeest with a YouTube account, so I'm going to focus on the larger species that do have one. Therefore, what is more likely to kill you? Crocodile versus a shark. The saltwater crocodile is the largest and most intelligent reptile on the planet. This species has barely changed since the time of the dinosaurs due to evolution's rule of don't fix it if it ain't broke, where it, in this case, is the ability to kill like vengeance incarnate. Camouflaged just below the water's surface, the crocodile struggles to keep its boiling hatred for all living things at bay. Then some lamentable creature upsets the gods who rule them. And those gods cause them to wander close. With an explosive rush, it bursts out of the water, grabs its victim, and drags it back in, turning it over and over underwater until the prey either drowns, bleeds to death, or because all the organs of the body are attempting to flee in all directions from so much concentrated evil. You'll find saltwater crocodiles living all over the world, so there's lots of places they can ruin a perfectly good vacation full of not being eaten. There are several reasons a crocodile might attack a human. 1. Defense. If you're stupid enough to wander into a crocodile's territory and make it think you're about to mess with its nest, or happen to be nearby during breeding season, you're probably dead. 2. Accidental. Maybe your choice to splash around in the water wearing that zebra costume wasn't the best idea. 3. Bad attitude. Some crocodiles, on top of already being 99% pure Armageddon, are also blessed with a bit of a grumpy disposition and will attack anything that moves. And the most important reason for attack, at least the one you should remember, appetite. Maybe, just maybe, that croc pulling you into the water while chomping down of everything below the spleen isn't suffering from fear for its babies or a case of mistaken identity. It may actually want to eat you. And now, by contrast, the great white shark. Like deadly retribution from a vengeful god, this shark is a cold-eyed horror from the deep. Along with the crocodile, the shark wins evolution's coveted no need to further evolve this creature because it's already maxed out at 100% pure evil award. Shark habitat is pretty much worldwide, but indeed, where the sea meets the land is where people continue to find themselves being digested. There are always lots of shark attacks every year worldwide, but the true number is likely higher since such attacks are bad for tourism and often aren't reported. Here are some of the different methods of attack the shark has in its binder of badass kung fu killing methods. The hit and run. usually a single strike in a surf area as a result of mistaken identity.
Thought you were someone else.
Or territorial dominance.
Get out of my ocean.
Injuries are minor. The bump and bite. This is when the animal is hungry and surveys the prey in decreasing circles, finally bumping into the prey to smell them. If the smell is pleasing, the bite. Repeat visits are common and injuries are severe. So don't wear the eau de sea lion cologne to the beach. Sudden strike. This is often by the great white. Repeat visits are common and injuries are so severe that often death results. So, now that you're familiar with the mind-extrudingly malevolent lethality of both animals, and you can appreciate they are both so full of hardcore concentrated doom, they could kill you so hard you'd be dead twice! Now is the time to decide which one has refined the art of human destruction down to a form pure enough to burn with the white-hot flame of everlasting intensity! Well, the highest year for shark attacks was the year 2000, when worldwide 79 people were attacked by sharks and 11 of them died. And the croc death statistic? Well, again, not all croc attacks are reported, partly because a lot of these attacks are in areas that are remote and impoverished, and also perhaps because the crocs will leave no trace. But per year, the figure is somewhere around 457, 311 of which are fatal. But it is not the number of attacks that should scare you. No, my friends, it is the math. Assume there are two of you, alike in every way, right down to how spectacularly unlucky you are. One of you is attacked by a shark, the other by a croc. Based on the ratio of attacks to deaths, your chances of survival with a shark are around 86%. You see, sharks don't really eat people.
Oh, hell. That's not a sea lion. I don't know what that is, but based on what it tastes like, it's full of chemicals and preservatives, and parts of it seem to be made out of surfboard.
And the other you, the one locked in the titanic struggle with the croc, this you has a 32% chance of survival. This is why the croc deserves the unremitting horror of your nightmares. The crocodile is the only predator on the planet that considers humans part of its natural diet. It's there to mess you up. It is not confused. It is not surprised. It wants you dead, and if it gets a chance, it will make it so, due to the epic concentration of deadly crammed into every fiber of its being. The winner of this contest